Okay, what I want to do here is I want to help us identify that this is a binomial distribution and what about it makes it a binomial distribution. And then I want to answer a few questions about the binomial distribution here. So when we're looking for a type of distribution, we're looking for a binomial, we're looking for a fixed probability. So we've been told we've got a probability of 0.3 of hitting this duck, and we've got a fixed number of trials, and here we've got the fixed number of trials, 12 shots. So we then have the other two requirements that each trial is independent. You assume each shot is independent. The fact that he missed the last time won't affect whether he hits it or misses the next time. And that we have got two outcomes. He either hits the bird, the duck, clay duck, or he doesn't. Okay, so shooting exactly 6 ducks, well, we want to get probability that x is exactly equal to 6. Okay, so what are we going to do? Well, we care about the probability of the parameters. We've got n, p, and x. In this case, n is it's always the total number of trials, 12. And the probability is 0.3. The only thing we're going to be changing in each of these questions is x. Probability of hitting exactly 6 is 6. X is 6. So what we're going to do is we're going to go either into the formula and just plug those 3 numbers into the formula, or you're welcome to go into your graphics calculator and use B. Let me get that right, otherwise we're going to get confused. B, P, D. Now why is it BPD? Because it's at a point. It is exactly that number. Okay, so x is equal to 6. So you're going to go in, and if you do it under BPD, you'll get 0.0792. If you've done it under BCD, you'll get a completely different number. It'll be all the numbers up to and including 6. The probability of getting 0 ducks, 1 duck, 2 ducks, 3 ducks, 4 ducks, 5 ducks, 6 ducks, which is not what we want. We want exactly 6 ducks. Okay, however, if we want less than 3 ducks, what do I want? Well, I've got the options. I want to have probability that x is less than 4. Okay, well, what's that equal to? Well, let's consider. We've got the number we can have to be less than 4. We can have 0 hit. We could hit it once. We could hit 2 ducks. We could hit 3 ducks. But if we hit 4 ducks, we haven't hit less than 4. So these are the only numbers we want. So we're going to use, in this case, BCD. We're using BCD because it's cumulative. We want to up to and including 3. So now, rather than having x being 6, we're going to make it 3. Okay, and if you put that in, you end up coming up with 0.4925. Shoots more than 5 ducks. Okay, so what do we want for more than 5 ducks? Well, we could either shoot 6, 7, 8, 9, 10, 11, 12. Okay, but we don't want to be shooting these ones, the 0, 1, 2, 3, 4, 5, more than 5 ducks. Okay, we don't want those ones circled. Okay, we want this. But the calculator won't give us that, so we have to do 1 minus this. So probability that x is greater than 5 is 1 minus probability that x is less than or equal to 5. So we're going to do the same thing, B, C, D, because we want up to and including 5, and we're just going to change x to be 5. Okay, and you'll end up coming up with 1 minus 0.882, 2 if we round, which is 0.1178. Now, I want you guys to make sure you do these questions, and make sure you can get the same answers in your calculator. Please, if you didn't go through at the same time with your calculator, now go through, make sure you can resurrect and get the same answers as I just did.